Right, these are our two CTDs from Seabird Electronics. And CTD stands for obviously conductivity, temperature and depth, but both these instruments have some additional sensors. This one here is our newer of the two, and as well as conductivity and temperature, we also have a pH sensor here and a chlorophyll fluorometer up the top here. On the older instrument, we don't have a pH sensor. We do have a chlorophyll fluorometer. We've got a PAR sensor up the top here, photosynthetically active radiation. That's got a cap on it usually, which needs to be taken off. Fluorometer has a cap too, which is a bit of a pain. And we've also got a beam transmissiometer, which has a cap on either side, which measures water clarity. When you're using the CTDs, it's usually best to pick one and stick with it for the duration of your studies. A, because they have different sensors on them, and B, because some of the measurements, for example, the chlorophyll isn't directly comparable between instruments. It's not calibrated, particularly with chlorophyll. If you want it to represent the amount of algae in the water, you really need to be taking your extracted chlorophyll samples as well as your CTD profiles. You're really just measuring relative concentrations of chlorophyll through the water column. Where else to start? So in the field, obviously, first thing you need to do is make sure you've got all your caps off. And we just took the caps off on that one. The pH sensor is a little bit trickier. There's a cage over it here. As with the other pH sensors we've seen, gets stored in a little bit of buffer solution there, so take that cap off. You can leave this, it's got an O-ring underneath it, so it won't slide off. You can leave that on there to do your profile. Make sure you don't kind of spill this or lose it. It's often ended up stored dry, and that's not really what we want. So when you're done, chuck it back on.
Do you leave the cage on? Do you put the cage back on to do your measurement? Or does that stay off?
It's really just protection. It's not essential for the measurement. It's up to you. If you're likely to run into sticks and logs at the bottom of where you're sampling, you probably do that. In terms of actually using it over the side of the boat, obviously you want to deshackle or a good knot on here on your rope. The way the instrument works is that it has a pump for the internal sensors, which is the DO and the conductivity and temperature. The pump actually cycles water through the internals here, through these tubes. There's an intake here and an outlet at the bottom of the instrument. So this depth here is where your measurements, your depth measurements are referenced to. That pump doesn't turn on when you turn the switch on. The switch is here. So down is off, up is on. You turn the instrument on, the instrument will start logging, but the pump won't actually turn on until the water that goes inside these tubes is of a certain conductivity. So what happens is you lower it over the side of the boat into the water, and there's a set amount of delay, and we always keep that delay at 60 seconds. So the conductivity sensor will pick up a reading that's high enough to flick that pump switch. The instrument will wait for 60 seconds, and it'll turn on, start cycling the water through, and then you're good to go. So the procedure we use is turn it on, hold it on the side of the boat, put it in, hold it over the side of the boat at the surface, like fully submerged but not deep, for 90 seconds at least. So it's always a good idea to time that rather than guess it, because a minute can seem like a long time when you're waiting for it to happen. And then once it's had its time to equilibrate, make sure you're right up near the surface if you're interested in that zone of the water column. And just start lowering it slowly, kind of hand over hand, depending on what kind of spatial resolution you want. Your instrument, I think, measures it 4 times a second, is that right? So you're getting plenty of readings. Hand over hand is usually pretty good. Yeah, so that pretty much covers it. One important thing though, with the conductivity setting, these instruments are used by both marine and freshwater students and researchers. And that setting needs to actually be changed for each instrument, depending on whether you're going to be operating the instrument in freshwater or marine water. And to change that setting, you need to hook it up to the software, which we'll go through shortly. Yeah. So before you're going to head out, make sure that you hook it up to the machine and actually check the settings, because it's not such a problem for you marine guys, because it'll definitely turn on, it'll get enough conductivity. But if you're operating it in fresh water and it's at the marine setting, you'll put it over the side of the boat and the pump will never turn on, so you'll get a slow response time in your temperature and oxygen profiles. So what we might do is hook it up to the machine now. Go over that.
Does it have a battery of parcels in that, or is it again fixed?
Yeah, there's 9 D cells which are in this central column here. You'll see the battery voltage readout when we hook it up to the machine, and get worried for myself to replace it if it gets supposed to operate, I think, down to 10 volts, but we generally replace them when they get down to around 12.
Chris, how many chlorophyll measurements do you recommend for a good calibration of the chlorophyll?
Probably depends how interested you are in the chlorophyll profile.
Right.
There's kind of a lot of, like chlorophyll fluorometry is a pretty complex issue really. There's a lot of things that can affect the way you calibrate these kinds of readings. For example, exposure to intense sunlight of the algae will actually reduce that fluorescence response. So if you just take an extracted chlorophyll sample from the surface and then scale your whole water column profile to that measurement, you might be getting that horribly wrong because the fluorescence is so suppressed at the surface layer. So if you're interested in the whole water column, you generally want to take a few different depths of chlorophyll.
Okay.
And different species assemblage will fluoresce differently and stuff. It's not like a one-stop shop for measurements.
It's about half a dozen different depths each day you use.
Yeah, it depends how accurate you're trying to be. It's very good at showing the relative concentrations through the water column.
Okay.
It's not so good at quantifying actual micrograms per litre chlorophyll.
Sort of R squared values you get, maybe order of 0.7 if you're lucky.
Okay.
But it's a very tricky thing because you get quenching and you might get a sort of dulled fluorescence response at the surface, and the surface is usually where the concentrations of chlorophyll are highest, which give you the robustness to your sort of calibration that you can see drew previously on the board. So it's a tricky thing.
Yeah, ideally you'd probably do it first thing in the morning if you've got the opportunity to do that before that effect really comes into play.
We're cleaning that after use.
Yep, that's a good point. Can't really do it now because it'll make a mess of the bench, but it's a 2-stage cleaning process. We have Triton detergent, which the actual concentrate lives on the shelves in the prep room, and that's 0.1% mixed with RO water. So it's just 1 ml to a litre of water. And do you have the syringe pumps here, Joe?
Oh, downstairs? Around?
Yeah. So we'll go over that after we do this.
Double X.
Is there much, because the pump will switch on at high conductivity, is there much point in switching that setting for young people? Can't just leave it at the lower setting?
Yeah, I mean, you probably could, but I'm just going off what the manual tells you to do, basically. So,
Because it's a pain in the ass when you change the setting.
I'm guessing the idea of it is so that the pump doesn't start sucking air as soon as it's turned on. So that basically the pump won't engage until it's actually immersed. Maybe it, is bad for the pump if it's on in air.
If it's like a little, usually you plug in a little rubber impeller, if they run dry, then they can cause cracking to the impeller.
Right.
The pump,
So
so they run them wet.
So the idea is that if you're out on the ocean or whatever, there might be some kind of residual, because you're in a salty environment, that might trigger that pump as soon as the instrument's on.
You've got you probably want to check the battery voltage anyway, so it's the same. You've still got to plug it in before you go out and check it, so it's not a big deal to check it and change it. You've got to log in and do it anyway.
So there's actually a separate, different cable, a different plug style for these two instruments. The newer instrument you plug in at the top. There is a plug at the bottom, but it won't work. The older instrument you plug in at the bottom, and you'll soon figure out which cable works and which one doesn't. So the two instruments are identified by their serial number. The new one is 6165, and the old one is 4268. There's a large pin on here, which is a locator pin, to get this plugged right way around. There's a computer down in the FC2 instrument room, which is set up to do this job. This latest laptop has all the software on it as well, and my personal machine has it as well. If you're having any trouble. The software is called CTD. And screen resolution's a bit screwed up. So what you often run into with, similarly with probably the hobo loggers and with any kind of instrumentation, in the old days you had 9-pin serial ports on computers. We don't really have these anymore. We have USB ports. So generally to communicate with the instrumentation you need an adapter, which is like that, USB to serial adapter. And each computer will store a what's called a COM port address for each specific adapter. If the software that you're using to communicate with the instrument isn't looking for the right COM port, then it won't be able to talk to the instrument. So it's a bit of a convoluted procedure, but essentially if you're not getting any communications, which we probably won't do here because it was looking for COM9, can't find it, we need to go into the control panel and find out what COM port the computer has assigned to the adapter there. So if we go to control panel, and then to system, and then device manager, Under ports, COM and LPT, should be able to see our USB serial port adapter there, and it's assigned to COM1. So we can change that, or we can just leave it as is. Now if we go to configure, under the CTD software menus, select our instrument type, which for both of these instruments is a SPE 19+. And we can see here our first tab is COM settings. Got a pull down menu there. Change the port it's looking for to match the port that's assigned to that adapter. Click OK. Now we should be able to connect to the instrument. So it's giving us a few readouts here. You can see in the top line here's the serial number of the instrument, 6165, with the new CTD. The way to check all the settings that are currently assigned is to type DS and then hit enter. So you can see here the battery's at 12.1 volts, so it's probably not far off needing to be changed. And the important one, minimum con frequency is 2681. So what was it? 2681. And this one is, what is it, Joe? 2567.
I think so, yeah.
So those are the freshwater settings, and if you want to change it for marine, just add 495. So on and so forth. So just quickly to change that setting, we need to type min cond freq, all one word, equals, and then our new setting, whatever that is, 3176. Now if we type DS again, we can check that that's gone through. And we can see min-con freq 3176. So we're now on the marine setting. So yeah, check your conductivity setting, check your battery voltage, and good to go. Should I go over the data unloading tab?
Chris,
It's more the conversion. Okay.
how do you feel? Do they want to see data unloading? Is it going to be worthwhile? Detail. Yep. Okay.
So, is there any there'll be data in here? So, if we go to upload, plenty of casts. So, when you've been out in the field and taken some casts, always make sure you download it as soon as you can, because you never know what someone else is going to do with the instrument. They might come along and intentionally or not delete all the casts that are there, and then you've lost your data forever. The software is set up on all the machines, I think, to select the cast range, and then it will download them all. So we'll just do like the last two. So we start with cast 81, finish with cast 82. Select OK, and it'll ask us for a place to save it. So we're just making like to give the folder a name that means something, so CTD and the unload date. What's the date today? 6th.
Yep.
And when you're doing dates on files, I reckon it's always good to put the year, then the month, and the day, and that way Windows or whatever will sort it in chronological order when you're arranging files later on. And I usually use that date for the cast name as well. So if we give the file name the unload date, it's a good way to go. And then software appends a cast number onto whatever file name you give it. So I always just chuck an underscore at the end. And then you'll get your date underscore cast number. Sit there and tick away for a little while. Big cast joke. Oh,
Tell us more about battery life. Oh,
What
that's
do I know?
Well, when is it crucial that you change it?
what I was told was that it would operate down to 10 volts. I've never looked that up to confirm it, but I always tend to change them when they get around 12. Usually we don't change the batteries more often than say 6 months to a year, depending on how heavily they've been used. So a fresh set of batteries will last a long time. So it's relatively rare that you need to replace it. But always with
What's the battery life?
just standard alkaline D cells. So runs on second cast.
And are these mostly used in lakes and all the big waters type systems?
Well, most people tend to use them at some stage. Yeah.
What do you mean, CTDs?
Yeah.
Oh, absolutely standard oceanographic equipment and top of the range, really.
Yeah.
Fantastic.
The sensors are a lot more stable than some of those other instruments that we've seen, so calibration is probably more the concern of techs around here rather than students who want to take the picture. But it's always worth, if you want good data, it's always worth checking the instruments calibrated recently. So that's done. We can disconnect now. Close that. So these files come out as .hex files, which is just gibberish. You need to convert them if you want anything useful. And that's done through a separate piece of software. SBE data processing. And what you want is data conversion. Looks like this is actually an old version of this. I could spend a fair bit of time on this, but try and just do it quickly. Really easy with this machine. So essentially, what you're getting off the instrument is just raw hex. It just looks like gibberish. And this data conversion software stores calibration parameters, calibration coefficients, and so forth for the instrument. And that's stored in these .conf files. So when you're converting your data, you need to make absolutely sure that your .conf file you're using matches the instrument that you've unloaded the data from. We need 6165 here, and it can't be read. Obviously don't have the right COM file for on this particular machine. So what I'll do is because I need to use this new CCD. see if I've got some old data somewhere. Didn't have any data in this thing, actually. Just finding a file we can work with here. Okay, so starting to do. We'll convert some files from the old CTD here. So we've got the 4268.con. Select your input file. So wherever you say. Where's users? I'm going to remember where that was.
Documents.
So it'll prompt you to change the output directory to the same as the input. That's fine. Now, basically, it's usually set up good to go, but you can go into this data setup tab and go. You can select either to interpret just the downwards pass of the instrument or the up and down pass. We usually just do the downcast. And you can also chop and change around your output variables that you're going to interpret from the raw data. So for example, you've got separate depths for salt and fresh water, your oxygen in milligrams per litre and percent sat, conductivity or specific conductance, whatever. I normally just do them all, but yeah, it's up to you. There's maybe some other possibilities you might be interested in here, things like sound velocity or whatever. So you can add and insert, delete, whatever you want, parameters that you can interpret. So once you got that, just start process. It's really quick. And that should be it. The .psu file is just basically the setup for the data conversion. You can save it or not, it doesn't really matter. And if we go back into here. Where was it? Sure, it was in CTD. So now we've got this .cmv file. You can either open that as a plain old text file, or if you want to deal with it in Excel, open it as a tab and space delimited text file through Excel. So you can see you've got your depth on the left hand side here, and then all your other parameters through here. And your column headings are all in the header of the file up the top here. So that pretty much covers it. Just not got any questions?
I did write some step-by-step instructions for all of this at one stage. I just haven't checked if they still work with the new software. So I know they're on the computer down on SC2.
The
Oh, the cleaning.
When you delete the files, there's only like an option there to delete the whole lot. Can you select certain files to delete?
Possibly, I don't really know. I've only uploaded from home. When you're cleaning it, we've got these syringe pumps here. Should have your 0.1% Triton and another bottle of just plain old RO water. Do your Triton first, suck some up the pump, and put it over the intake nozzle of the pump, and just force it through. Once with the Triton, once with the RO, and they just get stored like that, dry.